Hi guys, let's go ahead and talk about 19.2. We're going to talk about permutations and probability. I'm going to try. There we go. Okay. So permutations and probability. Well, a permutation is a selection of objects from a group in which order is important. The fundamental counting principle, if there are n items, so any random number of items, and A1, a certain number of ways to choose the first item, that means there's A2, a next number of ways to select the second item after the first has been chosen. So if you have cards numbered 1 through 10, so I've got 10 items. A1, the way to choose, the number of ways to choose the first item. If I'm picking a card, well, there's 10 possibilities that could happen, right? But if I pick that card and put it to the side, then I only have 9 left, right? So my A2 is now 9 because that's the number of options that I have from my sample now that I've taken one and removed it. That's what it means when it says order is important. So that many ways to choose the second item after the first has been chosen, and so on. So so the number of ways to choose the different items. If I had those 10 cards, it's A1 times A2 times A3, A4, etc., all the way down to AN, in number of items. So, for example, if there's a club that has 7 members, they need to pick a president, a vice president, and a treasurer. You can't be, if someone in the club is president, then they can't be vice president and they can't be treasurer. So that person is removed from our sample size. See what I mean? So a club has 7 members. They need a president, a vice president, and a treasurer. How many ways can this position be filled? So our A1 here is 7 times our A2, which is 6, times our A3, which is 5. So we have 3 different positions. Total number of members is 7, right? So there's 7 possibilities for president. Well, once we remove someone and they're president, then we only have 6 to choose from for vice president. And then once that person is removed, then we have president and vice president gone, which means we only have 5 members left to choose from. So when we multiply 7 times 6 times 5, we get 210. So there's 210 possible ways that the different 7 members of this club can be filled in the space of president, vice president, or treasurer. So probability using permutations. Let's see if I guess not. So probability using permutations is in factorial. In with an exclamation point after that, you say that as factorial. So in factorial, any number factorial is just that number times that number minus 1, times that number minus 2, times that number minus 3, so on until you get to 1. So a quick example, 4 factorial is 4 times 3 times 2 times 1. 4 times 4 minus 1, which is 3, times 4 minus 2, which is 2, times 4 minus 3, which is 1. That's why in the master equation here for n factorial, it's n times n minus 1 times n minus 2, all the way till you get to 1. So, by the way, we consider 0 factorial as 1. So, if we're talking about the number of permutations of n number of objects, taken r numbers at a time, it's given by this equation down here. This number of permutations r times is n factorial over n minus r factorial. Let's see what that could look like. So a quick example, is if we're selecting 5 digits that cannot be repeated from 10 digits. So our N, our total number of objects, is 10, and R, the number that we're selecting, is 5. So our number of objects in our set, okay, that is 10. That's our total number of objects. So 10 is our N, 5 is our R. So remember our equation was N factorial over N minus R factorial. And in this case, since our N is 10 and our R is 5, 10 minus 5 is 5. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. That equals 30,240. There's 30,240 possible outcomes to select 5 digits that cannot be repeated from 10 digits. So that's a lot. It's a lot of chances. Let's talk about permutations with repetition. So the number of permutations in objects where the object is repeated a number of times and another b number of times. So however many times you have repeating objects, that goes in the denominator here. So the permutations of the letters in Mississippi. Okay, so we need to figure out the total number of letters in our word. So Mississippi, 11. So 11 total numbers. That means our N is 11. We also have, we need to figure out our repeating numbers, right? Or our repeating letters. So in Mississippi, there's lots of repeating letters. Talk about S's. There's 1, 2, 3, 4 S's. How many I's? There's 1, 2, 3, 4. There's also 2 P's right here in the middle. So our permutations with repetition is N factorial, so 11. An 11 factorial is 11 times 10 times 9 times 8 times 7, blah, 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 all the way to 1. All of that over 4 factorial times 4 factorial times 2 factorial. So 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1 times 2 times 1. So 11 factorial is 39,916,800 divided by 1,158. That total is 34,650. Takes a little practice to figure out like what's your N, what's your R, what these different things are. So the first thing in a problem when you're doing these, the first thing you need to identify are your different variables. What's my N? What's my R? If you're doing permutations with repetition, what are my repeated elements? Start there, and then you can apply these different formulas to it. Let me know if you have any questions or if you hated me doing it like this. Go back to the other way with the paper. All right, bye.